Good morning, everyone. Good morning. Hope all is well. Everyone's doing all right.
Have her birthday brunch.
Say it again now. All right. I didn't quite hear that. Didn't quite hear that. If you want to repeat it. But yeah, so let's see. Where are we today?
What's up, brother?
Hey, how's
How
it
you doing?
going?
All right, all right.
Good, that's good. Let's see. Where are we? We did graph. We were in graphing. I'll make sure I was flowing with these notes here. Yeah, okay. So the last thing we did here was slopes and intercepts. So we're looking at slopes today. And your slopes, I believe this class has it at 4.2. So this is 4.2, still a part of 4.2. Remember we said intercepts and slopes. So 4.2. Let me check out one other thing before we get rolling. Okay, yep. All right. So looking at slopes. So the letter M will be what we use to represent slopes. S is already used a few times when we talk about in physics and whatever. So we can't use S, so they use M. So we'll be able to calculate our slopes by y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. Either one of those will work. We just have to make sure we stay consistent. If we do y2 first up top, make sure you use x2 first down bottom. Or if we use y1 first up top, make sure you use x1 first down bottom. And so in the first one that we'll calculate, I'll show you both ways, but you don't have to do both ways. Have to do, like I said, one way, and you'll get the same result. Then the other part of the relationship is rise over run, in which we will use that to graph. So we'll talk about that later when we get down to it.
I got a quick question.
Uh-huh.
So those exponents, the y1 and the x1, well, the exponent is the one. Why is that necessary?
So those are sub characters. So exponents are up high. These values are down low, subscript. So you got superscript and then you got subscript. So subscripts are down low. These are used for extra notation. So in other words, notice I said x1, y1, x2, y2, two different points on the line. So in other words, we only got 26 letters in the alphabet and we ran out of letters. So instead of using X and Y, we're using X1 and Y1.
Okay.
You know what I mean? So it's just another way of notating that this is 0.1 and this is 0.2. Because remember, all of your coordinates are going to have X and Y. So that's 0.1, which is X1, Y1, 0.2 is X2, Y2.
Give me 1 second.
Yep. And they represent,
So
when we calculate our slope, there's any 2 points on the line, we'll find the slope for you. What were you saying?
so those aren't exponents. Those are just different points on a line.
Exactly.
Right.
They carry no calculation value. You know, it's not like you apply the 2 to the Y and now
But
it's morphed. Mhm.
but the y is going to be something, and
Yes.
it's going to be okay. So
Yeah.
we're going to figure out what. Okay, all right. So that's
Yeah,
just
so
the
they're
basic.
they're gonna give you those coordinates, and then you're gonna use that to find the slope. So though the x1, y1, x2, y2 will be given, and then you find slope.
Is it obvious given, or is it in the form of those confusing word questions that you got to pick out and put it where it's supposed to be?
Nope, just like that.
Okay.
So find the slope, and then they give you the two ordered pairs.
And we can pick whatever one of those need to be y, whatever one need to be y2 or y1.
So whichever one you call point one would be x1, y1. Whichever one you call point two, x2, y2. Yeah.
Okay. All right. Cool. Can you scroll back up so I could finish getting that up there?
Mhm. All right. All right. So let's go ahead and do that. I'm gonna find the slope. They give us the points -2, -4, and 3, -5. So I decide, it doesn't matter which one you call point one, which one you call point two. I go ahead and just, first point I come across is point one, second one is point two. So I go ahead and label it, just for, those purposes, whatever. But most definitely, if you want to make sure that you label things correctly and put in things correctly, you want to definitely put those labels out there. So x1, y1, -2, -4, x2, y2, 3, -5. All right, so let's make sure we're careful with our substitution. So y2 is -5, and then y1 is -4. So notice what we have right here, -5 minus -4. Make sure you don't lose a negative. Sometimes, people will do that when they're substituting in values. There's a minus sign in the formula, and we're plugging in -4. So that's why it's -5 minus -4. So make sure you hold true to everything that's given. X2 is 3. X1 is -2. So that's 3 minus -2. All right, problems with the substitution. Negative to negative turns positive. So that's why we have -5 plus 4, 3 plus 2. That'll give us -1 over 5.
We're trying to find the rise and the run, or is that what M is?
Nope, that's all we're trying to find right here, -1 over 5. That is what M is. Mhm.
So the rise and the run is what we're given.
You going? We ain't there yet.
Okay.
Yep.
All
That
right.
has nothing to do. That has nothing to do with what they ask you right here. And all they asked you for was what was the slope, and that's -1 over 5. Yep. But we're gonna get there, of course. Yeah, most definitely gonna get there.
All right. Give me 1 second.
Mhm.
All right, so so this is just one part of the equation. So we just figured out one half of this.
No, that's the answer. That's it. That you good? Like I see like you're looking for more.
I haven't been like following along in your lab. I've been trying to write and listen at the same time, and it's just throwing me for a loop right now. And I don't want you to get too far ahead and then me not know. I mean, but that's part one. So that's so where it says part one, that's the left side. That's the y2 minus y
That's point one.
point one.
Yeah. So
Oh.
that's not part. That's point. Yeah. So ain't no other parts to it. So yeah, I didn't want to make you confuse that part. That's just point one and point two. I was just re-emphasizing. That's what I decided to call these. So if you're calling it point one, that's x. The coordinates of x1, y1 is point one. Coordinates of x2, y2 is coming from point two.
All right. So on the bottom where it says where you figured out the problem, it says 3 minus -2. Where'd you get that from? 3
From x1, yeah, on the bottom, from x2, x2, x1. See how it says x2, x1 down here?
x2 x1. Okay, I see that.
And so making that connection right here, our x coordinates.
x2 and x1. Okay. All right. Okay. I got you. I'm following now.
Okay.
Sorry about that.
Oh, you're fine. You're fine. So, so that is our answer, -1/5. Now, remember I told you if you wanted to, you could do it the other way as well. You don't have to. You only have to do it one way. I'm just doing it this way, showing you both ways this time on this one problem, just to show you that you'll get the same answer if you do everything correctly. So the first time we did y2 and x2 first on top and bottom. So this time we're going to do y1 first, x1 first, top and bottom. And so you're just flipping around your numbers. At y1 is -4 minus y2, which is -5. Then on bottom, -2 x1 minus x2, which is 3. And so when you do your calculation, negative turns positive. That'll be a +1 over -5, which is still -1 over 5. So you still get the same answer, but just wanted to emphasize that if you stay consistent in your substitution, in other words, y2 first, x2 first, or y1 first and x1 first, you'll still get the same result. All right, can I scroll up? Do it again. All right, so the next one, 5, -6, 8, 3. Once again, the first point I see I call point one, second one I call point two. So x1, y1 is 5, -6. x2, y2 is 8, 3. Formulas, y2 minus y1 over x2 minus x1. So y2 is 3. Y1 is -6. So that's 3 minus -6. X2 is 8. X1 is 5. So it's 8 minus 5 on bottom. All right, make sure we're okay with the substitution before we go ahead and calculate.
All right. So you said it doesn't matter which one we put, which one. So right now you made the y1 -6 and the x1
5. Oh, yeah, 5.
so Man, I'm lost.
All right, what part?
All of it. Just the substitutions.
Okay. So now this, do you see that this is Y2 in reference to 0.2?
But couldn't it also be Y1?
Yep. But remember, I told you that's why I did this.
So it doesn't matter which one you pick it as long as you do it in the order that
Mhm.
you keep it, then all right. So as long as you keep them in bunches,
Yeah.
I mean, keep them together.
Yep. Yep. As long as Y2 is first, if you do Y2 first on top, you do X2 first down bottom. Or if you do Y1 first on top, do X1 first on bottom, then you'll still get the same result. So that's why it doesn't matter which point you call which, as long as, in other words, if I use 3 first on the top, then I need to use 8 first down bottom. You see what I mean? You just have to make sure you stay consistent in what you're using first.
All right. So each one of the pairings is one of them is a Y pair and one of them is an X pair. So it's just X1, X2.
What X1, Y? Hold on. When you said, oh my, I keep forgetting I had this eraser on. So yeah, it's always X and Y. So if that's your point one, it's a X1, Y1. Those two always go together. And then the same thing, if I call, let's say if I call that point 3, y'all not going to see that, but I'm just throwing it out there. It will be X3, Y3. You know what I mean? Like it's always X and Y.
For the points. Okay, I get that. So this, and that's the axis. So 5 would be the X1, the 6, -6 would be the Y1. And it could be either one. All right, okay. All right, I get it now. I get it. All right, thank you.
Yep, not a problem. So to go ahead and finish off calculating our slope, we have 3 minus -6, negative to negative turns positive. And then 8 minus 5 is 3. So 9 over 3 is 3 when we simplify.
The X is always first. The X is always the first number.
In the order pair?
Yes.
Yes.
X is so okay. So that all right. Because I just yeah. Okay.
And now
Because
this formula, Y is on top, X is on bottom. But as far as your ordered pairs, X is always first, Y is always second.
but the formula is always consistent.
Yes.
And then in pairs is always consistent too. It's always going to
Yes.
list our X axis first.
All right. Make sure we're good before we go to the next thing. Is everybody done copying that part? All right. So there are 4 basic behaviors of your slopes. So you always read your graph from left to right. Reading it from left to right, if it's going up, like that first one, that means your slope is positive. Reading it from left to right, if it's going down, that means your slope is negative. If you have your a horizontal line, your slope is 0. And if it's a vertical line, your slope is undefined. Any problem with that? Like I said, just 4 general basic behaviors. If your graph is going up as you read it from left to right, your slope, that means your slope is positive. Reading it from left to right, if it's going down, your line going down, your slope is negative. Horizontal line, your slope is 0. Vertical line, your slope is undefined. All right, can I scroll up?
Give me 1 second.
Yep.
I'm on the
no
last
problem.
one. I'm
Yep.
sorry.
No, you're fine. Take your time.
All right, I'm good.
All right. All right. So we have 2 relationships that'll play a role in us moving forward and how we knock this stuff out. Parallel lines. They're lines that'll never cross or never touch. But if that's the case, that means they have to have the same incline, which means they will have the same slope. Means they will have the same slope. Perpendicular lines, when they intersect, they create a 90-degree angle. Their slopes are going to be negative reciprocals of each other. And we'll talk about what that means in a second. I want to give you guys a chance to write that down, though. All right, we done with parallel lines. All right, so parallel lines at their intersection creates a 90-degree angle. But the main thing for us is, as far as the slopes are concerned, they're going to be negative reciprocals of each other. So what does it mean to be a reciprocal? That just means you flip your fraction. So this first column is just talking about being a reciprocal. So if it's a reciprocal, you flip the fraction. 4/5 and 5/4 are reciprocals of each other. It's just a fraction flip, but you keep the same sign. -10/7, -7/10. Once again, they're reciprocals. All you did was flip the fraction. And 8, and then 1/8, flip the fraction. They are reciprocals of each other. All right. So no calculation. All you're doing is flipping the fraction. Now, when you're talking about negative reciprocals, negative in mathematics means opposite. So that means you're going to flip the fraction and then use the opposite sign. So if you're talking about slopes being negative reciprocals of each other, you're going to flip the fraction and use the opposite sign. So if you have 4/5, the negative reciprocal of that would be -5/4. If you have -10/7, the negative reciprocal of -10/7 is going to be +7/10. And then for 8, the negative reciprocal of that is -1/8. So once again, if you want a slope of the line that's perpendicular to another, you're going to flip that fraction and then use the opposite sign. All right. How are we? Can I scroll up or we still copying? All right, so next exercise under this, just going to further establish what it means to be a line that's parallel to another versus perpendicular to another. It says give the slope of the line that's parallel, then give the slope of the line that's perpendicular. All right, so the first one, if our original slope, oh no, what happened? Hold on, guys. Okay, sorry about that. All right, so the original slope or the given slope is 3/5. All right. So if you want a slope that's parallel to that, you will use the same line or the same number, which is 3/5. So parallel lines will have the same slope. Now, if you want a slope of the line that's perpendicular to the slope that has 3/5, you flip the fraction, use the opposite sign, and that's how we got -5/3. All right, questions on that? Make sure we're okay before we go to another one.
Can you go through that one more time?
So if you want a line that's parallel to another, the slopes are going to be the same. So that's why both of them are 3/5. So before I go to the next one, straight on that, make sure we're good, because I want to just keep jumping to concepts. If there's two lines that are parallel, they're going to have the same slope. So that's why both of these are 3/5.
What do those numbers represent? Like they're given numbers, but what do they represent?
We ain't got there yet. Right now, we're just talking about calculating numbers. So
Okay.
basically, when you talk about now, if you're talking about their directions, but we're going to get there when we get to rise over run, and you'll see the meaning of it. But they're talking about the steepness of your slope, steepness of your slant. I just put a numerical value on your, like you're talking about, whether it be the slope of the roof, slope of a mountain, slope of a ramp. It's just giving you information on the steepness of that and direction. And so when we get to the rise over run, you'll see the real application of how it creates a line based off of this information.
Yeah, I use the rise and the run stuff in carpentry.
So that's why you keep trying to go to it, because you keep trying to go there. And I'm just like, man, I'm taking us there, man. Just give me a few minutes so we go get there.
I'm just trying to make it make sense into what I do so I can understand it better.
But that's where it goes. That's exactly where it goes. I'm just taking it. I'm taking everybody where your mind is already, because see, you have that real life application. So your mind is already there. You know what I mean? So, but abstractly, we just talk about the numbers right now. And then we're going to get to how those numbers translate into directions to create that slope in that line. Yep. But yeah, you're on the right track though. So make sure we're good on that. So parallel lines, they're going to have the same slope. And then if you want to find a line that's perpendicular to it, you're going to flip it and then use the opposite sign. All right. So is everybody good with that? So here, if they gave us -11/9 as the slope, if I want a line that's parallel to it, once again, it will be the same exact thing, which is -11/9. If I want a line that's perpendicular to it, I'm going to flip that fraction and use the opposite sign. And that's why I have +9/11 for a line that's perpendicular to this given line. Questions.
So yeah, I got a question.
Mm-hmm.
So why on the -11 when you're flipping it, a -11/9,
Mm-hmm.
how come you don't go -9/11?
You got to use the opposite sign. So we started off with -11/9. So if you're going to find the perpendicular slope, you have to use the opposite sign and flip the fraction. So that's why it's positive 9/11.
All right, because negative 11/9 is the same thing as 11/-9.
11. Yes, yes, I
Okay.
see what you're saying. Yep, that's the same thing. Yep.
All right.
Mhm. Then one more, 1/7. Once again, if you want to line this parallel, then the slope is going to still be 1/7. But then if you want a line that's perpendicular, you flip it, use the opposite sign, so there's -7/1. Any questions, questions, questions? All right, kind of scroll up. So now we're about to get to graphing using the slope. So remember I told you rise over run is going to come up when we go to start graphing using our slopes. So rise over run, your slope is actually going to be a set of directions. It's going to tell us whether from a certain point we can go up or down, left or right. So your rise represents your up or down movement. Your run represents your right and left movement. So what will dictate whether you go up or down, then right or left will be if we have a positive number versus a negative number. Our positive moves will be up and right. Our negative moves will be down and left. Screwing up a little bit. So if I have +3 over +4, both of them are positive, so I should be making positive moves. So that means I'm going to go up 3 and then right 4. So once again, your slope is a set of directions telling us how to move. Scroll up all the way. All right. So then if I have -5/7, and your classmate did kind of allude to this already, whenever you have a negative number, the negative doesn't go to the top and bottom. It only is assigned to one of your numbers. So you have to make a decision. I always say just go ahead and give it to the top number. So in other words, having a -5 over a +7. Or you could do +5 over -7. It's going to change your direction slightly, but it will create the same line. So if I do -5 over +7, that means I go down 5, right 7. But if I were to do +5 over -7, that means I go up 5, left 7. But if I'm starting from this blue dot, if I go up 5, left 7, that'll put me here. When starting at the blue dot, if I go down 5, right 7, it'll put me here. Either way, the same line will be created as long as you just give the negative to one of those numbers, not both. Because remember, negative over negative is actually a positive. So that's why you can't give the negative to the top and bottom. So you have to give it to one or the other and then follow your directions accordingly.
Well, this isn't performing the task. I mean, this isn't performing the division that's implicating, right? We're not performing that division.
No.
So how is it that a negative over a negative equals a positive?
In other words, if I wanted to, you see how I wrote this 2 different ways?
Yes.
If I wanted to write this one the other way, I would do -3 over -4. You see what I mean? Negative over negative is equal to that was simplified to positive 3/4. So in other words, if I were to go down 3 and left 4, you see how this still created the same line.
Mm-hmm.
If I do the same thing up here and go up 3 right 4, that puts me over here. But if I go here and go down 3 left 4, that still puts me here and creates that line. You see what I mean? So the double negative really applies to this number versus direction wise versus, trying to apply that here.
So how do we know which one to apply it to and which one not to? I don't get it.
Well, you don't mess with the double negative because it's not necessary.
Okay.
And that's why I didn't even put it as an option, because that's adding more to the process that's not necessary. Now, once you get, more advanced and stuff, if you want to play around with stuff like that, you can, but it's not necessary for you guys.
Right.
Yeah, I wouldn't even mess around with the double negative. That's somebody ringing the doorbell. Hold on 1 second, guys. I gotta see, because he not leaving. So I gotta make sure. One of the joys of teaching from home, right? Give me a second. Sorry about that, guys. Sorry about that. All right. So, all right. So let's go here. We're going to use that to graph. But one more thing I need to introduce, which is the slope intercept form. And that's y equal to mx plus b. So if your equation is solved for y, whatever's sitting in front of your x will be your slope, and then the other number will be your y-intercept. And we'll talk about how that connects in a second, but this is introducing that equation, y equal to mx plus b. Once you solve your equation for y, or if your equation is already solved for y, what's sitting in front of x is your slope, and the other number is your y-intercept. Okay, well, you're all right. So just as an example, we have y equal to 2/3 x plus 1. What's sitting in front of x is our slope. And then the other numbers are y-intercept. Here, if I have negative 8/13 x, once again, what's sitting in front of x is my slope. The other number is my y-intercept. All right, any problems with what we're connecting right now?
What's the X?
X is just like when we had our regular equation before. You can plug in, if you want to create, if you want to graph, you can plug in a value for X, like 0, and then find Y. So that's all that is. That's the same flow that we had before. Right now, we're not talking about the X because we don't need it in order to graph your equation if you're going to use your slopes. All right. So once again, X and Y are just values that, when you create the XY chart. you know, it will reproduce your ordered pairs that will be produced by the line. All right, can we scroll up? All right, so here goes our steps to graphing using slopes. I could have put that up there. So we're going to plot the y-intercept first. Notice I tried to emphasize that first. That's the first thing you have to do. And then we're going to generate another point from the y-intercept by using the directions of the slope. All right, so make sure you hold true to what we're saying here. You're going to generate another point, not from the origin, because remember, your slope is not a point, it's a set of directions. So you're going to generate another point, not from the origin, but from the y-intercept. Now you graph points from the origin. So this y-intercept, you would go to your origin, then move accordingly. But your slope is a set of directions. Your slope is not a point. So your slope has to generate another point from a point that's on the line, and that is our y-intercept. So let's look at that first. One of those equations that we were looking at, y equal to 2x minus 1, 2x cubed, not 2x cubed, I'm messing all up. 2x over 3 minus 1, or 2/3 x minus 1. If I can get it right. So we already said that our slope is 2/3, our y-intercept is -1. So now what comes along with that is more information on both ends. So if my slope is 2/3, then that means as far as directions are concerned, +2 over +3, that means I go up 2 and right 3. All right. If my y-intercept is -1, that means my ordered pair is going to be 0, -1. Because don't forget, for all of our y-intercepts, x is always 0. So that's always the case. So before we do anything, questions on what we have as far as the information is concerned, this information here. 2/3 is your slope. That's the number that's sitting in front of x. -1, the other number that's not attached to x, is our y-intercept. So once again, your slope is directions. It's a set of directions. Your y-intercept is an ordered pair. All right. So your y-intercept, you always graph that first. And that's my green point right here.
So your y-intercept is going to be a x and a y direction.
As an ordered pair.
As an ordered pair. So it's going to be an x is always 0 on the y-intercept. All right,
exactly.
so it's going to be 0. All right.
You got it. So that means you're not going to go right or left. You're just going to go according to whatever's on the x-axis. So, I mean, that y-axis. So here is -1. So that's why we're right here at -1. You know, if our ordered pair was 0, 5, then I would be right here. You know, I didn't move left or right. I would just be at 5 on the y-axis. All right, so we graph your y-intercept first. Then from your y-intercept, I'm going to go up to right 3. And that's how I get to this purple point. So make sure we're okay with that. I went up 2 and right 3 steps. And that's how I get to the purple point. Notice once again, I generated that next point, that purple point, from the y-intercept. Just kind of trying to make sure we don't have this mistake of going to the origin, because I've had people do it before. Just trying to make sure we eliminate that. Yes, sir.
The M is the purple dot.
No, your M is your directions. Your M is never a dot.
Up to right 3. It
Right,
creates a point.
It creates a point, but that's not like 2-3 is not necessarily going to be associated with your slope. That just so happened to be the case. You see what I mean? So let me see. No, this ordered pair is like, if you look at this ordered pair, that is 3, 3, 2. And like, there's no correlation between that. That just so happened to be a coincidence that that's 3, 2, and this is 2, 3. That will not always be the case.
So where those 2 points come from? Where did the purple point and the green point come from? The
now
first point,
the green point comes from here,
the y-intercept.
the
And
y-intercept.
you do that first. That's your
Mhm.
you do that first.
Right.
When you're trying to graph using slope, you do that first. You find your
Exactly.
y-intercept first.
Mm-hmm.
So how come you make a move on your x-axis first if the rule is, I mean, does it matter?
Yeah, because x is 0. So because x 0, then you don't move right or left because you don't have any directions as far as that is concerned. It's 0. Because now remember, if x was 2, let's say if it was 2, -1, then the first thing I would do is go to the right 2, then down 1. But because x is 0, you don't move right or left. You just go down 1 for your y. All right. So is that cool? That's all right. So then, as far as this purple dot is concerned, now, like I said, this point and these directions don't necessarily have to correlate. Like, it's not like that ordered pair is going to always be 2, 3, or anything like that. No, those are directions. So from your y-intercept, you're going to go up 2 and then right 3. And whatever point that is, then that's your coordinates. But it has nothing to do with your directions here. But that point is generated by these directions. And then what that also does for you is that if you want, you can continue to make points. So let's go ahead and connect these dots. So that's gonna create my line right there. But if I keep going up 2, right 3, I will continue to have points on this line. Up 2, right 3, up 2, right 3, up 2, right 3, up 2, right 3 will always be on this line. So that's what the slope is. It's just a set of directions that will continue to generate points and continue to create this line that we have right here. Questions, make sure we're okay.
So I'm still not okay with.
Mhm.
So I'm understanding the green dot. I see where that came from,
Mhm.
and then the purple dot
Mhm.
is your directions
Mhm.
to go up 2 and right 3,
Mhm.
and then that creates the line, and then you just connect those 2 lines and then continue it on, and then those
Appreciate
2 directions continuously, though M continuously would get you just continue points on that line.
Mhm.
Okay, maybe I am understanding.
Sounds like it to me, sir. All right. Anybody else before we do another one? All right. So the next one, they give us y equal to -1/4 x plus 3. Oh, 1 second. Hold on 1 second, guys. Why y'all look at that? All right. Let's finish this thing off, y'all. Sorry about that. Like I said, when you're teaching from home, man, get any type of interruptions. So we
I got a
have,
quick question.
yes, sir. Yeah, what you got?
Why does it matter that we plot the y-axis first?
Y-intercept first. Because your slope is not a point. It's a set of directions. So really, if you don't plot the slope, I mean the y-intercept first, you really have nothing to generate another point off of.
You're
See what I
starting
mean?
from zero.
Well, that's what I'm
Like,
saying. You start from zero when you have a point.
oh,
But
so we started from that point and went up two and right three.
exactly.
I got you. Okay. All right. Now it makes sense. All right.
Yep. And the reason why is because that point is your only information as far as what is on the line. The only thing that you know that's on this line is this y-intercept. And so since you have one point on the line and you know the slant, which is the slope, now you can generate more points that will create that slant that you have now.
It makes sense now.
Cool. All right. All right, so the next one, and yeah, last one, unless somebody want another one. We have -1/4 x plus 3. So what's sitting in front of your slope? What's sitting in front of x is your slope. And then the other number, once again, is your y-intercept. So with that, we have -1 over a +4. So that means down 1, right 4. And your ordered pair 0, 3, 0 is always going to be the coordinate for your y-intercept for x, for your x component. And so once again, we graph that y-intercept first, and that's what we did here. Just went up 3 on the y-axis. And then from that point, just like your classmate just mentioned, from that point, we go down 1, right 3. And that's how we get to this purple point. Once you have those 2 points, that's all you need. And whoa, missed the line strong. Okay, let's see if I can make it better. Yeah, still kind of missed it, but it's good enough. And so that's your line. Any problems? Any problems? Can I scroll up? I think I got this one. Let me see something real quick. I'll go back. Yeah, we can do that one since that one wasn't solved for y yet. Okay, make sure we all good with this one before we do this last one. The first two, the equation was already solved for y. So in this next one, we're going to solve the equation for y and then pick out our slope and y-intercept. Try to make sure you guys are fully equipped, or at least have, enough notes to lean on when you do your work. So we have 5x plus 2y equal to 8. What we need is for our equation to be solved for y, so we can just pick out what the slope is and what the y-intercept is. So if it's not, then we need to go ahead and solve it for y. So we want to get y by itself. So the first thing you do is subtract 5x from both sides. That'll give you 2y equal to -5x plus 8. Divide both sides by 2. And whenever you're doing that, this 2 has to go to each term that's in the numerator. So you can't just give it to the 8 and not give it to the 5x. So be careful with that. And so this is that breakdown. Remember, our goal is to get our equation to this form, y equal to mx plus b, because what's sitting in front of x then will be our slope, and then the other numbers are y-intercept. So simplify. Y is equal to -5 over 2x plus 4. So let me know. I'll give you a chance to write that down, but let me know if you have any questions.
So negative, so that first fraction, the negative 5x over 2,
Mhm.
that's the same thing as negative 5 2x. Say it the same? Like
Negative, you can say either -5x over 2, or you can say negative 5 over 2x. I think that's what you were saying. Yeah.
yes.
Mm-hmm. Yeah, yeah.
Okay.
As long as the interpretation is not -5 over 2x. You see what I'm saying? Like the emphasis and how you say it, you know what I'm saying, can direct people in a different way. And of course, this would be wrong. So if you say -5 over 2x, so you just got to the how you say, what's the word? The influence, not the influence, but
So
anyway,
how
I'm
do
not,
you
huh?
how do you determine when you can move that x to wherever you want to make it make sense in your equation?
Now that x should never be in your denominator. It's either going to be up here in the numerator or be on the outside beside the fraction, but it'll never be in your denominator. That's a whole different type of problem.
Okay.
Yeah, that's a whole different ball game. Yeah.
Okay.
All right. So we have our two pieces of information now that we can extract from this equation. Inflection was what I was looking for. Inflection of your voice. Inflection. All right. So -5 over 2 is our slope. The y-intercept is 4. So that means our y-intercept coordinates will be 0, 4. And then I have -5 over +2. So that's down 5, right 2. All right. Any problems with that before we graph? All right. So first thing we did was graph that y-intercept. That's 0, 4. We just go up 4 on the y-axis. All right. And then from there, we go down 5, right 2. And that's how we get this point right here. And once again, we're going from this point and we go down 5 tick marks, right 2. And that gives that point, and that is our line. Any questions? Any questions?
So is it always going to be given to us like this? Like we're not going to have to decipher word problems and dig out the information, put it in the right place. It's all going to be given to us just like this.
Not, yeah, for this, yep, that's how it's going to be given to you. Mhm. Yep. Let me see if there's anything else in there that they may ask you to do. Okay. Get the points from the line. So they give you the numbers there, give you the numbers there. They give you the equation there. So even if they have small word problems, they give you the numbers. So it's not like you have to pick it out. They give you the diagram. In other words, like they give you a ramp with and they got 8 feet right here, 3 feet right there. Ask you the slope. Well, your slope is rise over run. So that's going to be 3 over 8. You know, your rise is 3 and your run is 8. So stuff like that.
Thank you.
Not a problem, not a problem. But if you see anything and you feel like, you know, you need more clarity on it, just, you know, let me know. We'll go over the problem. It's not a big deal. So. All right. Anything else before we close out today? All good, everybody straight. Okay, so next class we'll get into creating equations with these slopes and all the stuff like that as well. Other than that, you guys have a great weekend. Be safe, and I will see you on next class.
Okay,
Can I get,
All right, take care. What'd you say, sir?
I was trying to go back to another section, not on this, on
No problem. Thank you.
compound interest.
Okay.
It's kicking my butt. So I am trying to get you to just show, you know, do a few problems for me.
All right, what you got?
I don't have specific problems. I was hoping
okay.
that you could just pull some random
Not a
examples.
problem. Okay, cool. So you said
Just like one or
compound.
two, just so I can get the program going and then roll with it from there. One or two probably should jumpstart me, man. I'm that's where I am on my homework assignments, and I don't want to take that test and not be ready for that.
All right, so is this one good?
Whatever compound interest you got and you can help me with, I'm fine with it, bro.
Oh no, what I want to do is make sure that, you know what I'm saying, the problem I choose, you know, addresses, you know, whatever it is that you got going on. Because I don't want to pick a problem and it really don't, you know, you'd be like, oh, I was cool with that. Like, you know what I mean?
Yeah, no. This whole thing baffles me.
Gotcha. So, before I do that, so notice it says interest is compounded annually. Find the amount in the account after the given length of time. So we got 3,100 as our principal, 7.23%, and then 6 years.
And there's something that has to be a decimal, but is that already a decimal?
When you say that,
I mean,
already a decimal. Are you talking about the rate?
Says rate always has to be in decimal form.
Right. So if it has a percentage beside it, it's not considered in decimal form. It's considered a percentage.
Even though it's 23.7. So then you still got to just
because it
move
says
the decimal.
Yep, because it says 7.23%. It's not in decimal form. It's in percent form because of that percent sign.
Okay.
Yeah, you know, I know it's weird, but mathematically that's how it's perceived.
Okay.
So
as long as I can understand the rules, if I can understand the rules of this, then I can apply the rules to whatever. But some of these, like it's hard for me to, like when I'm asking you about like the word problems and how it's, you got to pull and decipher and put the right, because if you take one thing and put it in the wrong place, then everything's wrong.
Yeah, most definitely, for sure.
But you still get an answer.
Oh yeah, you'll get an answer. That's true too. So let's go ahead and do this. So like you said, 7.23% has to be converted to a decimal, moving your decimal 2 places to the left. So that's 0.0723. All right. Then were you about to say something?
No.
Okay. I thought I heard you say about to say something. Then it says compounded annually. So that means n is going to be equal to 1. So now that's going to be a word. They always give you a compounding. Well, I don't say always. For the most part, they're going to give you a compounding in a word. So whether it's, and I gave you those, lists of translations, whether it's
Yep.
annually, semi-annually, quarterly,
Mhm.
and that will dictate what n is going to be numerically.
hmm
All right, so now we're going to use the formula. That's going to be P times 1 plus R over N raised to the N times T power. That's multiplication, N times T. Now, I know you got that TI. So you can put it in the calculator this way. 3100%, that's a one, not percent, but parentheses. 0.0723 divided by N is 1. Raise it to the power of 1 times 6. So you can put it in the calculator just like that, and you will get your answer. So
Can I try that real quick? Can I try
Yeah,
to put
yeah.
it in my calculator real quick?
Yeah, tell me what you get, and then I'll throw it in MATLAB to make sure it's correct.
3100. So you put the equal sign out front. So I just got to hit the equals first.
No, that's just a part of the formula. That part, A is
Oh.
equal to this. That's all I'm saying. So in
Okay,
other
so
words,
that's
you can
just-
just keep. Yeah,
That's just a habit for you to write that every time. So
formulation and then
Okay.
notes, board, all that stuff. Yeah.
so 3100
Yeah, this is the only part you put in the calculator.
parentheses 1 plus 0.0723 divided by 1 parentheses parentheses 1 times 6 parentheses enter 4712
4712
588616.
So yep. So now this is we're dealing with money. So they're gonna expect you to round it to do 2 decimal places, unless they say something different. So it should be 471259. So let's make sure that's good as far as MATLAB is concerned. Yep, that's it.
And we just found out how much interest they paid every year.
Well, this is how much money will be in the account after 6 years. Because remember, that's what we're looking at. So it compounds annually. So this is how much money will be in the account after 6 years. Now, if you want to find the interest, you would subtract what you originally had. Remember, you originally had 3,100. So you subtract 3,100 from that amount that's in the account. And so it's going to be 1612.59. So that represents the interest earned.
So what's the principal? The principal is 3,100. That's what we had in the account first.
Initially, right? That's what
I
you
thought that's what
deposited
the
into
amount
account.
was. What's the A? The A is the amount.
Oh, A represents future value.
So it doesn't represent amount. It represents future value.
Right. Unless you want to call it the amount in your account after 6 years. I mean, but A represents basically future value. What's going to be in the account after so many years?
Yeah, see, I think that's what I was doing wrong. I was putting the principal where the account was, and like I was trying to find the P, and I was like, man, I can't do this. I don't know how to do this. It doesn't. Nothing makes any sense.
Check the notes again. I should have in the notes. It should have said A should be equal to future value.
You probably did, and I was all, and I just wrote amount. So when I'm looking back at my notes, I'm looking, and it says amount in there, and I'm like, oh, Kev, this doesn't make no sense, Kev.
Yeah, and so
all right, so future value.
And just a heads up on math, everything's not always what it begins with. Remember, slope is M. But the reason for stuff like that is because the letter that we would like to use, S, is already taken up in other math. So in other words, we go to physics, you got speed, you got position, you got different ones that use S already. And you can't just keep using S everywhere or it will be confusion. You know what I mean?
So
So
really,
Mhm.
really, there's letters that mean specific things in math. Like
Mhm.
no matter what they are in any equation, if you see them, you automatically know what they represent.
Mhm.
So how
And
come
then
we use X and Y and stuff so freely in the stuff that we do?
because
And
it's understood that X and Y are more general. So you're hard pressed to find X and Y being used specifically. You see what I'm saying?
okay,
There are certain ones that are specific and are certain ones that are more of general use. Um, and sometimes in math they'll use M generally, but for the most part, whenever you see M, you're talking about your slope. So
okay.
yeah. And then like there, you even get into Greek letters. The further you get along, because you ran out of letters, so you had to go Greek. You know what I mean? So yep.
All right. All right. That just made a whole lot of sense.
Okay, cool.
To what I was doing. I'm gonna give it a shot.
Mhm.
Myself, man, and I appreciate your time. I ain't gonna hold you up no more today, man. I know you got some stuff you gotta do.
Okay, no problem, man. But you know how it is, man. If something causes you some issues, just hit me up, man. We'll make it happen.
Yes, sir. Yes, sir. I appreciate you though.
All right, man. Have a good one.
Yeah, be safe out here.
Yeah, man.